With the existence of so many sorting algorithms, HeapSort is the most significant and efficient one. Well, surely it's a myth that HeapSort is rarely used in practice, as it is widely used and has so many real-life applications. It is because of the fact that no extra space is used for sorting, as the heap can be constructed in the same array where we got it as the input. To understand heap sort in a more better way, we here at Great Learning have come up with this video on heap sort algorithm. Before we get started, I want to introduce you to Great Learning Academy, a free initiative by Great Learning, where you can access over 200 plus courses with 1000 plus hours of free content on trending high demand domains such as data science, machine learning, artificial intelligence, programming, cloud computing, digital marketing, DevOps management, and many more. Absolutely free. Award-winning academicians and leading industry experts design these courses. You can also get a free certificate of completion when you enroll and complete these free courses. You can also get access to the presentations, code notebooks, datasets, and quiz. We have courses in English and Hindi to give you the best learning experience in the language you are comfortable with. Check out the description of this video to access the relevant course on Great Learning Academy. So what are you waiting for? Register now and start your learning journey today. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notifications bell so that you don't miss out on any new updates or video releases from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video any queries or suggestions, and I will respond to your comments. Now, before getting deep dive into the concepts of heap sort algorithm, let's see what are the topics which we will look into in this particular video. The first thing which we are going to cover is what is heap sort and why do we use it. Following to that, we will see the step-by-step execution of heap sort algorithm. And I'll be taking one example, and using the diagrams, I'll be demonstrating how this heap sort algorithm actually works. Following to that, we will see the particular algorithm and understand every step of that algorithm. Next, we will go and see the implementation of this particular algorithm in a C programming language. So we will write a program in C programming language for heap sort algorithm, and I'll demonstrate you step by step how that program works. Last but not the least, we will discuss what is the space complexity and time complexity of this particular algorithm. Now, let's go into the first topic of the agenda, which is what is heap sorting. So before starting heap sort, I must tell you that there are so many sorting algorithms which we can use, such as bubble sort, merge sort, quick sort, and one of them is heap sort algorithm. Now, what is the sole purpose of these sorting algorithms? We use these sorting algorithms to arrange a list of elements in ascending order or descending order. So if you have a list of elements which is jumbled up, it is not in sorted order, these sorting algorithms will make sure that your list of elements will be sorted. It can be either in ascending order or in descending order. Now, this heap sort algorithm uses one of the tree concepts, which is heap tree. Now, tree concepts, when I say, I mean that it's a hierarchical tree concept. Now, if you look at the diagram given below, you can see that it's a tree concept. Now, there are a list of elements which I have taken here, which is 7, 15, 6, 8, and 4. And I have arranged it in a heap tree concept. So if you can see, 7 is the parent node. So we call that as a node, and 7 is the parent node. From 7, it is getting divided into two child nodes, which is 15 and 6. So we can say that 15 and 6 is the child node of 7. If you look into 15, 15 is a child node of 7, but it is also a parent node for 8 and 4, right? So we can say that 8 and 4 are the child nodes for 15, which is also a child node of 7, right? Okay. So this concept is called as heap tree concept. Now let's look into the third point, which is very, very important. So heap tree can be of two types. One is minimum heap and other is maximum heap, which is also known as min heap and max heap. Now what happens in max heap? Max heap is used to arrange a list of elements in ascending order. That means you can see in the heap tree which I have given here, it's all jumbled up. 15 is kept somewhere in the middle and 8 is kept in the last. There is no order here, right? Now when you do a max heap, there will be a particular order which is ascending order. So all the numbers in the heap tree has to be designed and kept according to the ascending order. While in minimum heap, what happens? It is used to arrange a list of elements in descending order. So just the opposite of what you will do in max heap, you will do it in min heap. So you have to start from the biggest number and you have to go down. Something like this. So if I talk about min heap and if I create a heap tree of the list of elements, for example, if I take these numbers, it will be something like this. Here it will come as 15, then it will come 8, 7, 6 and 4. That is what is descending, right? And the opposite of this, which will be ascending order, will be a max heap. We will discuss max heap more in detail in the next topics, because in HeapSort algorithm topic, we will be covering how to convert a heap into a max heap, which we will see in the next topic in our agenda. Now let's see the next topic in our agenda, which is step-by-step execution of HeapSort algorithm. So what are the steps which we need to take to complete this sorting algorithm? Now, before starting the step 1, I must tell you that these steps are really very important for you for the whole video. Okay. So when I'm reading step 1, step 2, step 3, please keep memorizing that what are these steps. It will be really helpful for you to understand the whole video if you understand these 5 steps. Well, I will be explaining using an example and a diagram, but make sure that you remember these steps. Let's start with the step 1, which is we first build the heap using the given elements. That means we will be provided with some 5 elements or 6 elements, and we have to create a heap tree out of it. Numbers can be kept anywhere, that's not a problem. So if I have a list of elements, I have to build the heap. That's it. That is step 1. What is the next step? Once you create the heap, you have to convert it into a max heap. Now, if you remember in the previous topic, I told you that max heap will be used in HeapSort algorithm, and max heap always follow ascending order. That means the heap which we will create, we have to convert it into a max heap which will have the elements in ascending order. We will see how we can convert this, and I'll tell you the steps for that also. Once you converted your build heap into a max heap, next what? Let's see the step 3. Once the sorted max heap is created, we swap the root node with the last node. That means root node is a parent node. The parent node will always be swapped with the last node, the extreme last node. No matter what the element is there, it has to be swapped. Now when it is swapped, the last element you need to delete it. That's what it's written here, and delete the last node from the heap. So that means you have to delete the last node from the heap. So you will be left with n minus 1 elements. Okay. Now, some of you must not have understood this, but in the later topics, when I'm taking one example, I will be telling you what is this step 3 and how to do it. So stick to the video till the end. Now, step 4, we have to repeat this process of swapping the parent node with the last node till you get only one element left. That means till the heap gets empty. Once the heap gets empty, you will get your sorted list. And then you can display your sorted list. So this is what is the 5 steps of heap sort algorithm. Now, before moving into the next topic or before moving into the demonstration, I must tell you one thing. If you look into the step 3, it says once the sorted max heap is created, right? When you are creating a max heap, you need to focus on one thing. That one thing is that your parent element should always be greater than your child elements, or it can be equal, but your parent element should always be greater than or equal to the child nodes. So now let's move into the next topic, which is the demonstration. And here you guys need to focus a bit more, because now is the time when I will be taking one example and I'll be demonstrating how this sorting algorithm works. So remember the 2 steps which I told you. So let's revise those steps. Step 1 is we first build the heap using the given elements. And we then create a max heap to sort the elements in ascending order. So let's first see what are the elements are we getting. So these are the elements which I'll be taking for an example. So the elements are 7, 15, 6, 8 and 4. And as you can see, these are unsorted and we have to use the heap sorting algorithm to make it sorted, right? So that's why I've written consider the following list of unsorted numbers which are to be sorted using heap sort. Okay, now let's build the heap. So if you can see, randomly I have just created the heap tree, which is something like 7, 15, 6, 8 and 4. And the numbers I have written down below. The step 2 was that I have to create a max heap out of it. So let's transform it into a max heap. When I do that, it looks something like this. Remember the point which I told you. I told you that when you create a build heap into a max heap, you have to make sure that parent node should always be greater than the child nodes. If you can see, 15 is a parent node which is greater than 7 and 6, which are their child nodes. So it's perfect. But when you look upon 7, 7 is a parent node for 8 and 4. And 8 is greater than 7, right? So don't you think we need to make this max heap more accurate? Yes, we have to make this max heap more accurate, right? So right now my max heap contains this. Now I think we need to swap this 8 with 7 because parent node should always be greater than the child node, right? Now if you look into step 3, we will do that swapping again, but first let's see what is a step 3 so that you don't forget what are the steps. Step 3 says once the sorted max heap is created, remember till now you have not created the sorted max heap. There is an error, right? A slight error is there. We swap the root node with the last node and delete the last node from the heap. So once I will do all those swapping and all, once the max heap is created, we have to swap the parent node with the last node and the last node should be deleted. And we have to repeat this same process until you get only one element in your heap, right? Let's quickly do this. So remember I told you that in max heap parent node is always greater than or equal to child nodes. Now see, I have swapped this 8 with 7. Now can you tell me if everything is in order and it's a perfect max heap? Yes, we can say that it's a perfect max heap because all my parent nodes are greater than the child nodes. So what is the step 3 now? So once you have created the max heap, we have to swap the parent node with the last node. Last node is 4 and parent node is 15. Should we swap it? So when you will swap it, you will get something like this, right? Now after swapping, you are getting something like this. Now what we have to do? A step was that we need to remove the last node, right? So we should remove the last node and 15 is gone. What is the meaning of that this last node is gone? That means 15 is sorted and it is kept at the last. So 15 now we don't have to work upon because already 15 is the most highest in this list of elements, right? That's why I have marked it as red in color. Okay, I hope till here there is no doubts. Now let's move. Before moving into the next slides, let's see what are the numbers we are getting here and is it a max heap? So if you look here, 4 is a parent node. Is the parent node greater than the child? No, right? 8 is and 6 is much more greater than 4. Don't you think we need to swap these? Okay, before that, let's see what is here. 8 is the parent node and 7 is the child node. And this looks perfect, right? Because 8 is greater than 7. Let's move and let's see what we will do. Max heap parent node is always greater than or equal to child nodes. So we have swapped the 4 and the 8. 4 was here and 8 was here. We have swapped it so that 8 comes to the parent node. Now still, is it a perfect max heap? I don't think so, because 4 is again a parent node and it is much more smaller than 7. Don't you think we need to swap this also to make it a perfect max heap? Let's do that. So you can see now we have swapped it and now it's a perfect max heap because 8 is greater than 7 and 6. 7 is greater than 4. And that's what I'm always repeating. Parent node is always greater than or equal to child nodes. Now what we should do? We have to swap the parent node with the last node. So let's do that. We have to swap the first and the last node and delete the last node from the heap. 8 was here and 4 was at the last. We have swapped it. Now that we have swapped it, we have to remove the node. Which node? The last node. So we have removed the 8. Once you do that, you are left with 4, 7 and 6. And 8 is removed. That means it is sorted. So I've marked it in red in color. 8 and 15 is sorted. Now we have to only work with 4, 7 and 6. What next? Obviously we have to repeat this same process, right? So you can see that it is not a max heap again. We need to convert this into max heap. Now you guys must be knowing what should be the next step. I don't have to tell that, right? So parent node is always greater than or equal to child node. So we have to swap that. 4 and 7 is swapped. Now is it a perfect max heap? Yes, you are right. It is a perfect max heap. You can see 7, 4 and 6. 7 is the parent node which is greater than 4 and 6. What next? Yes. So see, the steps when you cover it or when you know that what are the steps, you generally figuring out on your own what are the next steps and how we can sort it, how we can go with the algorithm, right? And that is why writing the algorithms or writing the steps are very much needed. Correct? Let's do this and complete this particular algorithm. Let's see what is the sorted output we'll get. Okay, so we have to swap the parent node with the last node and we have to delete the last node. Let's do that. So I have swapped the parent node with the last node, which is 7 and 6. It is swapped and we need to remove this 7. So we will remove that 7 node. It's gone. And we are getting the sorted one, the half sorted list, which is 7, 8 and 15. 7, 8 and 15 is already sorted now. We are left with 6 and 4. Looking into this one, do you think it's already a max heap? Yes, it is already a max heap. So what we have to do? Yes, we have to swap the parent node with the last node. So It's very simple. We have to just swap it. Once you swap it, you have to delete the last node, which is 6. You are now left with only one node, which is 4. That means we are now in the end of this sorting algorithm, and we can display our sorted list, which is 4, 6, 7, 8, and 15. Now this was a very easy and simple demonstration of HeapSort algorithm. Let's see what are the algorithms we have to check when we are writing a program in C language. Now, when we talk about the actual algorithm, we actually talk about the real-time code which we'll be using in our programming language or in the program, so that it becomes easy for us to write the program. So before seeing the actual program or the actual implementation, let's first see what we can actually come up with an idea to solve this HeapSort algorithm. So what we need is, we need two methods here. One is heapify, and the next one I'll discuss after this. So let's first see what is this heapify method and what we have to do here. So basically what we need to do here is, we need to make sure that my program, whatever I will write, it should be knowing automatically that which one is parent node and what is its child node. So we have to use a basic formula to do this. And if you can see, I have written a question here, how to find the left and the right child of a parent node. So suppose if the parent node is 7, what logic I can write so that my system knows that 15 and 6 is its child node. How can we do that? Let's see what formula I have written and let's discuss this. So if you look here, it's written left child of 7. For finding the left child of 7, which is having the index 0, right? When you write it in an array, this list of elements, obviously the 0 index element will be 7. If anybody who doesn't know what is index, basically when you write an array of elements, we represent it by the index items. So index numbers. So if you say 0, 0 is the first list of element. The first element. When you write 1, it's the second one. When you write second index, it's the third element. When you write third index, it's the fourth element. And when you write fourth index, it's the fifth element. So that's why left child of 7. 7 is the index 0. So I have come up with this particular formula, which you can see, 2 into 0 plus 1. That means 2 into, let's say I is the index. So I plus 1, right? If I say 2 into I plus 1, 2 into 0 plus 1 will give you how much? It will give you 1, right? Because 2 into 0 is 0 plus 1 will give you 1. What is the element in one index? 15. Are we getting the left child of 7? Yes, we are getting the left child of 7. If I have to find the right child of 7, what logic we can use? We can use the same logic. We just have to mention here plus 2 rather than writing plus 1. When we do that, what will happen? 2 into 0, 0, 0 plus 2, 2. Element in second index. What is the element in second index? Second index, not second element, right? Second index I have 6, and that is what I am getting here. So we have come up with two formulas. How can we find the left child of my parent element and the right child of my parent element, right? In this particular method, which is heapify method, we will be using this concept when we will come to the topic of implementation. So remember this concept. Okay. Now let's see what is the another method which I was talking about. I've just given a similar example of left child of 15 and right child of 15. So if you can see, left child of 15 is 8 and the right child of 15 is 4. How we have done that? The 15 index is what? 1. So I've just, in that formula where I was 0 in the previous example, I have just taken 1, and 2 into 1 plus 1 gives you 3. What is the element in third index? 8. And 2 into 1 plus 2, which is 4. What is the element in fourth index? 4. That's how this formula works to find the child of the parent node. Okay, let's quickly see the another method, which is heap sort. This is the method which we will use to basically complete the two steps, which is step 3 and step 4. Now, I hope the people who are concentrating in this particular video, they must be remembering the step 3 and step 4, right? Step 3 was, once the max heap is created, the sorted max heap is created, we have to swap the first node, that means the parent node, with the last node, and we have to delete the last node, right? That's what we are going to do here in this code. I'll explain you this now. So if you see here, for I is equals to n minus 1, right? N minus 1 means what? N is the size of the list. Size of the list is 5 in my example. So 5 minus 1 will give you 4, right? I is 4. 4 is greater than equal to 0. What does that mean? That means it is asking, is that condition true or false? 4 is greater than 0, that is true. So it will come down. What is there in ARR 0? That means the parent node, isn't it? Always the 0 index will be the parent node, right? And ARR I is what? 4 here, right? And that's our last node. So we are swapping that here. Can you see? Swap is a method inside which we will write the 3 steps for swapping something. I hope while you are learning C programming language, swapping is the very first thing or very first program which you have worked upon. And you guys must be knowing how we use temporary variable to swap two items, right? If you don't know, then stick to this video. In the next topic, I have written the code and I have explained you how we can swap the two items. Meanwhile, just understand that here we are calling the swap method so that these two items can be swapped and removed. I mean removal of the last node, right? Okay, so I hope this particular code you have understood. This is the step 3, which is this for loop. And if you see, you must have figured out that I skipped this part, which is the first for loop. Why I skipped this part? Because it is calling the heapify method. We have already seen how this heapify method works. That's why I skipped this and moved to the next for loop. Okay, so let's see what all things we have seen here. We have seen this for loop, which is calling the heapify method. Inside the heapify method, what we are doing? We are writing an algorithm to find the left child and the right child of our parent node. And in the next for loop, what I am doing, I am swapping the first node, which is the parent node, with the last node, and I'm removing that last node, right? And the last, you can see why I'm calling the heapify. Heapify root element to get highest element at root again. Remember one point which I told you while I was demonstrating, that when you are creating a max heap, remember always that parent node should always be greater than the child nodes. So if you want to make sure that parent node is greater than the child nodes, you have to call this heapify method, which is arr, I, 0, to do that heapify thing again and again, so that always your parent element will be the highest one. That is why we will write this and we will call this method heapify. Now, because it is an algorithm, it is kind of half of understanding of HeapSort algorithm, that how we can write a program. But now in the next topic, we are going to see how we can actually write a code and what is happening inside that code. How are the numbers moving from here and there, and how this build heap is converting into max heap and all the other steps. So let's quickly see the implementation of C programming language for HeapSort algorithm. You must be knowing that whenever you start writing a C programming language, we start with the main method because that is the heart and soul of the program. So let's see what all things we are writing in main method and what are the methods which we are calling from here. So if you can see in the main method, I have written an array, obviously, which is very, very important because you need to have the unsorted elements, which you need to write it in an array format. So I am taking the same example, which is 7, 15, 6, 8, and 4. Now, what is this n variable doing here? N variable is nothing but taking the size of the array divided by the size of the 0th index of the array. Now, this is not even important to write because in the n, basically, I want the length of the array. My length of the array is 5. So remember always that n will be 5 in the whole program. So if you already know the elements, you can directly write n equal to 5. But if you want to mention it in a formula basis, you can write size of ARR, which will obviously come at as 5. If anybody who is very new to C programming language, int is nothing but the data type. So the array is containing only integers. That is why I'm writing here int. N is a variable which is also containing only the integer, which is 5. So that's why I'm writing here int. And if you have any question regarding this main method, why is int written here? So we can write void also, but void is no return data type. That means when you write void, it doesn't return anything. But when you write int or float or any other data type, it should return something. So it all depends on you. If you want to write void, you can write here. There's no problem. Now, let's see what are the methods which I'm calling. And once I'm calling that method, we will directly jump to that method and we will see what is happening there. So in this particular video, please stick and please analyze how step by step these programs are running. Okay, let's start. So we are calling one method which is HeapSort, and it is having two parameters, which is an array and a n variable, which is here. So let's jump to this HeapSort method. Okay, and let's see what all things is written inside that HeapSort method and analyze that. And after those all things, we will come back to this particular slide and we will see what is this printf and printArray method. Cool? Okay. Now, if we go to the HeapSort method, ARR is the array. That means this all 5 elements is coming inside this ARR parameter. And inside n, obviously 5 will come. So let's move to this HeapSort array. Now, if you can see, this is the HeapSort array and the whole program is written. Do you remember in the algorithm also, I showed you the same kind of algorithm where we were calling the heapify in the first for loop. In the second for loop, we were swapping the parent node with the last node. And at last, we were doing heapify again with the 0th element because we want that parent node should always be greater than the child nodes. The same thing I've written here. But in a very deep manner, let's understand how each of the for loop is working. Okay, so remember when we were calling the heap sort, two things were coming. One was the array and one was the size of the array. So here all the array elements will come, and in this particular parameter, not all the, so basically the n, which is the 5, will come, right? Now let's first see what is this first for loop. We will understand this for loop. Once we will understand completely what is this, we will again come back and we will see this for loop. Then we will understand this one. Again, we will come back and we will see this heapify, right? Let's quickly see this particular portion. So this particular portion, what is happening? A for loop is there in which is written I equal to n by 2 minus 1, right? Let's see what is happening here. So remember, this is my unsorted list, right? Now, if I imagine that n is 5, right? So 5 by 2 will always give me 2.5, right? And 2.5 is approx to 2. Why I'm approximating it? Because my I is an integer. I can't take a decimal value, which is 2.5. So I'm approximating it, converting into an integer and taking it as 2. Now to that 2, I have to subtract 1. So how much is left? 1. That means I value is 1, right? Now, what is in the condition of for loop? It's written 1 is greater than equal to 0, which is basically true, right? Now, once it is true, what do we mean by that? We mean that loop will run from 1 to 0. First, this condition will be true. It will go and call heapify method. So that means it will call heapify arr, 5, 1. Once that heapify completion of the code happens, it will come back to this for loop. It will decrease the I value to 0. And again, it will call the heapify method with the value arr 5, 0. Right? So that is why I'm saying that loop will run 2 times. Once when the I value is 1 and once when the I value is 0. So don't worry, we are going to see both the looping thing. We are going to loop it 2 times and we will see in a very detailed manner what is happening when it is calling the heapify when I is 1 and what is happening when it is calling the heapify method when it is 0. Okay, let's quickly go and see what happens when I value is 1 and it is calling the heapify method. Heapify method looks something like this. And I hope you must be remembering that in the algorithm, I told you how to find the left child and the right child of a parent node, right? That's what is the formula I have written here. Can you see this? Guys, don't look at the whole code. You will get disturbed because it is much of codes are written here. Don't look at that. Just look at the 3 lines which I have bolded enough, which is this part, right? And why I have written this formula? Because I want to know that what is the left child and the right child of the parent node. Okay, let's do it very slowly and precisely. Let's not quick it off, right? So let's understand only this portion first. Okay, we will see the rest of the code after this. So let's see what is written here. I hope you remember that we are first taking I equal to 1, right? So when we are taking I equal to 1, does that mean this largest equal to I means largest value will become 1? Yes, it will become 1. Let's put the formula and put the values inside the formulas. So left equal to 2 into I plus 1. Left equal to 2 into I plus 1 will give you 2 into 1 plus 1, which is 2 into 2 will be 2, 2 plus 1 will be 3. So left is 3. Left is 3, okay? Now, tell me one thing. When my I is 1, which is the one index in this array, in this list of element? 15, right? One index is what? This is 0, this is 1. So 1 is 15. Largest equal to 1. That means largest becomes 15 for now. Largest is 15. For left, what is the number I'm getting? 3. So let's go to the third index. 0, 1, 2, 3, which is 8. Now if I look in the diagram, am I getting the left child of the largest node, which is 15? Yes, that means my formula is working fine. What about the right one? For the right one, I'm getting the index as 4. 0, 1, 2, 3, 4. For fourth index, the value is 4 itself. That means 4 is the right child of the 15 largest node. Yes, it is. That means my right formula is also working, right? So now my system knows that which is the left node and right node, I mean left child node and right child node of this parent, right? Because see, computer does not understand this heap tree, right? We can see the heap tree because we are designing it, but computer can't design it, right? So we have to tell the computer that, you have to figure out a way. I'll help you with that. I will write a formula and you have to figure out what is the left child node and the right child node of the parent. So now we know that this particular formula is working and we got the left and right. Remember, we are using the heapify method with the value I1. Still, we are left to do the I equal to 0. Remember that and keep it in mind. I don't want you to forget that. Okay, so this is done. Let's see the rest of the code, what was there. Till here we have done. There is a 3 if conditions and we need to check all the if conditions, which one is correct and which one is wrong. So let's work on that. Now I have just kept this list of elements and the heap tree in place so that you can always refer to this and analyze how the indexing is done and how the swapping is happening. Okay, so for your understanding, I have kept it here. So should we start doing this if thing? So let's complete this if conditional statements. What is written in the first if conditional statement? It's written left is less than n. What is the left value which I got? I think I got 3, right? 3 is less than, n is 5, right? The size of the array. I hope you must be remembering that. So 3 is less than 5 and ARR left, that means what is the value inside the third index? Third index, the element is 8. So it will be 8. What is the element inside the largest? Largest was 1, right? What is the value inside 1? 15. So I have kept it there. Now let's see which condition is true and how this AND operator is working. If anybody who doesn't know what is AND operator says that when your both the conditions are true, that is the only time when your whole condition will be true. So both the conditions has to be true when you're using an AND operator. But we can see here that 3 is less than 5, which is true, but 8 is greater than 15, it is false. So what does it result in? It results in false. That means, can you see this statement, largest equal to left? It will never work. That means it will never work. That means we have to ignore this sentence. Just ignore it because my condition is only wrong, right? Should we go to the next if? Please don't get confused here. It's not written else if. It's written if. If it would have been written else if, then we do not have to go to this if because it's saying otherwise or it's saying else you do that. But right now it is not saying else, right? So we have to go with this if condition. Let's see what is here happening. Right value was 4, if you remember, and n is 5. Then ARR right, what is the fourth value? Fourth index was 4th, right? So 4 is greater than ARR largest. ARR largest was 15, which is one index. ARR 1 is 15. I got 15. There is same AND operator used here. So let's quickly solve this. 4 is less than 5, true. But 4 is greater than 15. Again, it is a false statement. And AND operator says that when both the conditions are true, then only your result will be true. But as you can see, one of the condition is false. The if statement is also false. That means you have to ignore this particular line also, right? But still there is a chance because we have one more if. Let's see what is that. Largest not equal to I. Largest value was 1. I value was also 1. 1 is not equal to 1. That is wrong because 1 is equal to 1. So these two lines, again, we need to skip it. I hope you understood these all things. So that means, what does it mean? It is just saying that, you know what? Your max heap is sorted here. You do not have to swap any item. You can see that 15, 8 and 4, it is a perfect max heap. 15 is greater than 8 and 4. You do not have to swap anything. That is why all the conditions came wrong. That is what we are doing here basically, these all things, right? So for 15, which is index 1, is sorted. But remember, we have one more Heapify. Yes, so we have just completed this Heapify ARR 5.1. Now we have to go and take a look upon what will happen when I'll go to Heapify ARR 5.0, right? Let's quickly go to the Heapify and let's see what happens when I give the I value as 0, right? So I have come back to this particular program again. And if you can see, I have this particular 3 lines. Yes, we need to do that because I value got changed, right? I is 0 now. That means largest is 0 now, right? Largest is 0. Let's do this. So this is the arrangement which I have got. For your reference, I have got it here so that you don't forget that what we have done till now. And if you can see, largest will be 0. That means 0th index. What is there in 0th index? 7. So largest is 7 now. Now you must have understood that this is wrong. 15 should come here, right? 7 should come here and 6 should come here, right? That means here, those 3 if conditions, some of the if condition should come correct. Then only we can decide and swap these 2 elements. Okay, before going to those things, let's understand one by one. I equal to 0, largest will become 0. And if you look into the left and right, let's find it. Left equal to 2 into I plus 1, 2 into 0 plus 1, which will come 1. So let's check whether I'm getting the correct one or not. Left will be 1 index. If I go to 1 index, what is there? 15. Is my 15 the left child node of parent? Yes, it is. If I find the right formula, 2 into I plus 2, 2 into 0 plus 2. 2 into 0 will give you 0. 0 plus 2 will give you 2. Right? Now, what is the second index? 0, 1, 2. In the second index, I'm getting the value 6. Right? So, whether it is my right-hand side child of the parent, yes, it is. So it's working fine. Now keep it in mind 3 things. I value is 0, largest value is 0, left value is 1 and right value is 2. And let's see the if conditions, how we can fit it here and how it will work. Fine. Left was 1. 1 is less than 5. ARR left, that means ARR 1, which is what? 15, is greater than ARR largest, which is what? 0. ARR 0 is what? 7. 15 is greater than 7. Same AND operator, that means I'm again repeating, if both the conditions are true, then the result will be true. So 1 is less than 5 is true. 15 is greater than 7. Perfect. It is also true. That means my condition is correct. It's true. When it is correct, what will happen? Largest equal to left. That means largest will become 1, right? Largest becomes 1 now. Remember, now largest is not 0. Now largest is 1. And if you see, what is there in 1? 15. Right? Okay. Now let's quickly go to this next if condition and let's see whether this is also correct or not. Right value was 2, right? If you remember. So 2 less than 5. ARR 2 is what? 6. And ARR largest. Remember, now the largest value has got changed to 1. So we have to see ARR 1. What is ARR 1? ARR 1 is 15. So we have to write here 15. Okay, my bad. Here 15 will come. Okay, here the 0 will not come. We have to change this ARR. It will be 1 and it will be 15. I'm so sorry. So here there is some mistake. So it will be 6 is greater than 15, which is false. 2 is less than 5, which is true. So true and false will give you false because both the conditions are not true. That means we need to ignore this statement. Now the main part here is, are you understanding what is happening? We are just telling the computer that computer, you have to understand that you have to only swap these two elements, that means the parent with the left child, because right child is in the correct position. It is in the correct position. It is less than the parent node. So it is in the correct position. We don't have to even touch the right child. And that is why this condition came as wrong. Because we don't have to do anything with the right hand side part. Correct? I hope you are understanding. Now, let's move to the next if condition. What is happening? Largest is not equal to I. Okay, largest, what was the value? 1. 1 is not equal to I. I is nothing but 0, right? So yes, it is not equal. That means that's true. So we have to come down to this swap method, right? Let's see what is happening in this swap method. Okay, I have just explained that this is true. So swap method, we have to come in. Swap method, what is written? AND operator is an ampersand, because in C language, we use the concept of address and pointer. So whenever you are swapping, you are basically using the pointers, okay, which will hold the address of that particular location. If you don't know the concept of pointers, then please revise it and then come back. So if you can see, pointers will be using here, and that is why I've written ampersand. Ampersand will take the address of this location. Let's first analyze what is this ARR I. Remember, I was 0. So ARR 0. ARR 0 is what? 7. ARR largest. ARR largest means ARR 1. What is that? 15. Swap those two things. So it will swap those two things, means 15 will come here, 7 will come here. Perfect. And it will become a max heap, right? Let's see how this swapping is happening, because I told you that I will be explaining how we are swapping two elements. So let's do that. I'm just writing here that ARR 0 and ARR 1 is the numbers which we are taking and going to the swap method. Let's go to the swap method. This is how I've written the swap method. And if you can see, I've used the pointer. Pointer is always denoted by the star, which is also called as asterisk. So here comes the value ARR 0, which is 7. And here comes the value ARR largest, which is 15, right? 7 and 15. Remember, why are we putting the pointers? Because we want to swap the value using the address of those locations. Okay. In C, this is how you do it, because it is called as call by reference. That means call by address. So we do this. Now, some of you who must be knowing C programming language, I know you are connecting to me. Okay. Now, let's see how this swapping is happening. So if you see, this was the number 715, 684. When we do this formula, which is temp equal to A, temp will have the value 7 because A was 7. A equal to B means A will become 15 because B was 15, right? And then B equal to temp because temp was 7, B becomes 7. And thus, A becomes 15 and B becomes 7. Swapping is done. Now, one thing to notice here, that don't get confused why we are using temporary variable. See, we are using temporary variable because without temporary variable, it's very difficult to swap two things. Because if you are thinking that you can swap like this, A value give it to B, B value give it to A, it won't work. Because when you give A value to B, B value is gone. Then what you will swap from B value to A? Because B value is already done, right? It's gone. So that is why to save that value in a temporary variable, we use the temp, right? Once this swapping is done, you will get this array, which is 15, 7, 6, 8, 4. Now this looks a perfect max heap because here all the parent nodes are greater than the child nodes. 15 is greater than 7 and 6. Now look here, 7 is again an error coming here. That means we need to again do the heapify thing. And it will, because there's a for loop, right? Okay, let's come back. If you can see here, we completed this swap, right? We completed this swap. Now if you can see, we have left one program, one line of code, which is calling of Heapify method with ARR 5 and the largest, which is 1. Imagine that if it goes again to the Heapify method, then what will happen? It will again take the largest as 1 and it will again check whether the left right child is there or not, and again it will check the if conditions, and there it will find that the 7 and 8 was not sorted. It will sort it, and then again it will bring up the perfect maxim. So this is how this whole program is working again and again, right? So I hope you understood this part. Now we have covered this portion of the heap sort method, right? We are left with the next thing, which is nothing but the for loop, in which what we are doing, we are solving the step 3 and step 4. I hope you remember. The step 3 was, once you create the maxim, you have to swap the parent node with the last node and delete that last node, right? Let's see how we can do that. So this is the code which we are going to look upon now. And remember, we sorted the array. So it will come something like this when it becomes a perfect maxim. Okay. Now, once the sorted maxim is created, we swap the root node with the last node and delete the last node from the heap. Repeat the same until maxim becomes empty. So what we gonna do? I equal to 5 minus 1, which is 4. 4 is greater than equal to 0, which is true. Swap ARR 0, that means ARR 0 is 15. ARR I, which is ARR 4, which is 4. Swap it. 4 will come here, 15 will come here, 15 is sorted, make it red, right? I hope you are connecting with me. Now, we don't have to write again the same logic for swap because we have already seen, right, how the swapping happens using the temp variable and using the pointers. So let's see what is next. These all things are done. We have created the perfect maxim, we have swapped the parent node with the last node, and we have removed the last node, and we got the sorted. This will keep happening again and again till you get the sorted list of numbers. Now, if we come back to this main method, I told you that these all things are happening inside this heap sort method, but we are left with printing it, right? So we are printing sorted array with a /n, which is nothing but a new line. So if you know C language, you must be knowing what is /n. And then we are calling this last method, which is print array ARR comma n. Print array is a method which is taking the array with the n value, which is the 5, right? So now let's see what is going to happen when we print this. This is very easy. In the print array method, one code will be written in which you will be printing all the stuffs, right? All this sorted array. Now, because this is very easy, we will see at the last. Let's first revise what all things we have seen and what is the flow of the program, okay? So first we started with this heap sort, right? The heap sort takes us to this heap sort method. And then we have looked upon this Heapify method. In the Heapify method, we have seen a lot of coding. The first code we saw that how we are finding actually we are helping the system to find the left child node and the right child node of the parent. Then we have 3 conditions of if, and we are checking which one is largest, which one is smallest. And if it is the smallest, then we are swapping it. Everything is happening here. How to swap? We saw that using this particular technique, which is using the pointer, using the address, and using the temporary variable. After swapping, we again came back to this Heapify method, and we saw that how can we continuously creating the maxim so that a perfect maxim can be created and sorted, right? After that, we again came back to that heap sort, because once this for loop is completed, we have to come to the step 3 and step 4, which is we need to swap the parent node with the last node, and we need to delete that last node, right? One thing to notice here, Actually, in writing a program, we don't delete the last node. It is just kept untouchable. So we are not touching that particular sorted list or element because it is sorted. We don't want to touch it. So when I say that we are deleting, when you're writing a program, it's not getting deleted. It is just sorted, untouchable. We don't have to do anything with that 15 or any of that number. Okay. So we saw how to swap this parent node and the last node, and how to make the last node untouchable, right, while writing the program. And after that, we are coming into this print array, which is the method, print array method. And we have seen how to print this particular sorted array. It's a very easy thing. You are using a for loop and you're calling that one by one. So all the elements are getting printed one by one. This is the sorted element which I am getting. I hope there is no doubt, and I have clearly and very easily explained all the codes one by one technically, that how and from where the code is going, how the calling of method is happening. If the calling of method is happening, then how the values are getting swapped, how the values are getting conditionally true, and what are the if conditions, how those things are working. Now that we have understood how this heap sorting algorithm is done, what is the technique, and I have also demonstrated using an example and a diagram how this heap sorting algorithm works, creating a max heap, build heap, right? Let's discuss what is the time complexity and space complexity for this particular algorithm. Now, if you can see, in the worst case, what are we doing in every iteration? We are transforming it into a max heap, right? That's what at the final we are doing. Hence, this will perform log n operations, right? Because every time we are converting it into a max heap, right? So it will perform log n operations, and this has to be done for n iteration, resulting in n log n operations in total. So in the worst case, it will be n log n. Okay, that will be the time complexity in the worst case. Now let's see in the best case what will happen. In the best case, it is already a sorted array, right? We can do some modifications by using flag to check whether the element is already sorted or not. So suppose the element which you are getting is kind of sorted, only one particular element you need to shift, or you need to shift those elements. So in the best case, again, it's already sorted or not sorted. We are not complexing it, right? Or we are not spending much time in that. We will just create it into a max heap and sort it. That's why the best case will also be n log n. That is why the best case time complexity will be O(n), which is big O of n log n. Average will be also big O of n log n, and worst case will also be big O n log n. That is the reason many real life applications or many real life developers are creating applications using HeapSort algorithm. Let's quickly discuss the space complexity, which is only big O of one additional space is required because the heap is built inside the array to be sorted. Remember that whatever sorting we are doing, we are not using any other memories, right? In that memory itself, everything is happening because we are converting my elements into a heap tree, correct? Shifting of elements from one location to another is not at all happening. Every sorting thing or every sorting shift is happening inside the same heap memory, right? That is why not even a single additional space is required, because the heap is built inside the array which is to be sorted. Second point, data in an array can be rearranged into a heap in place, right? Data can be rearranged here and there in the same array, right? Hence, the space complexity is big O of 1, right? Okay, so we are coming into the end of this session. I hope you understood how this heap sorting algorithm works and how this particular demonstrating of heap sort algorithm, implementation, algorithm, and all of these things are happening. I hope you found it very easy, and I hope you will use HeapSort algorithm in your further developments, and all the best. We'll meet you soon. I want to introduce you to Great Learning Academy, a free initiative by Great Learning. You can access over 200 plus courses with 1000 plus hours of free content on trending high demand domains absolutely free. Register now to complete the course and get your free certificate of completion. Check out the link in the description of the video below. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notifications bell so that you don't miss out on any new updates or video releases from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video any queries or suggestions, and I will respond to your comments.